All right, today we're going to take a look at the debugger, which will help you to go step by step through your code and figure out what might be wrong. So let's start by creating a new project. We will call this debug. Now, to make it interesting, let's just make some random code. So I'll start by just creating a little function, int fun. And all this function is going to do is get a random number. And let's make that a random number from 0 to 100. Pound include stdlib.h to get the rand function. And this should return temp. And let's say for our main loop, let's just get that random number from the function and do a CY delay. Let me just build it, make sure it looks okay. Okay, and let's go ahead and click the debug button. Now, because we are debugging the CM0 right now, we're actually going to click on the CM0. And you'll see that the little yellow arrow here tells us where in our execution of the file in main cm0p.c. So it starts out right at the very beginning at boot. And we have three options. We're either going to step into, we're going to step over, or step out. So I'm just going to step over and kind of get to a spot that's interesting. So here's where we have our x. And let me just step over and see what happens. Okay, so x, which should be the result of this rand, seems to be this long hex value. Let's change it to decimal just so we can see what that actually means. Okay, cool. And I'm just going to test that it changes each time. All right, so nice. Let's try stepping in next. So we can step in. We can actually look at what's happening inside of this function. But most importantly, what I want to point out is that you can actually tell the trace of how you got to that function. So you went from main to fun, and then we can come back out, step out, and we're back in main again. Now there are three different types of breakpoints that I'm going to show you guys. One is just by clicking here, creating a breakpoint. And what that will do is it will stop the execution when it hits that line. So I press play and it stopped right here because that's where I wanted to start debugging. Now let's say I wanted to wait for a certain condition. So this is a very simple piece of code, obviously. But let's say you have a bug and it always happens when x is equal to some value. So let's create a condition. So let's say whenever x is greater than 80, the code crashes. And so we want to stop only when x is greater than 80. Go ahead and press play. Give it some time, and let's see what x is. X is 93. Cool, so it's greater than 80. And if there was an error occurring for x greater than 80, then we could stop here and take our time and see what's wrong. The other option we have is to use a hit count. So say a certain problem occurs only after maybe like, let's do 5 times of hitting this line. We could just fast forward and wait for it to hit 5 times and see what the value is. So, okay. Now, to compare the 3 methods we have, we've already talked about using the printf, we've talked about the SLAA, and now we've looked at the debugger. So what are the advantages and disadvantages? Well, the printf has the advantage of it goes to your console, you can print a lot of information, whereas the debugger, you can see where you've been, you can see the variables values, and you can even look through memory and see if you're doing a lot of mallocs and stuff like that, and using memory in a way that's more fine-grained. You can look at that level of detail, which you can't do in a printf. The downfall of a printf is it will require that the device goes and sends that information over UART, so it changes the timing of the execution. So if your bug is something that occurs sporadically or rarely, by changing the timing, you'll change how that bug acts. The same thing with this debugger, you're pausing it. So things like Bluetooth will not work in the debugger, in debug mode. That's where the SLAA comes in. The SLAA can operate fully in real time. So the SLAA allows for much faster feedback. The disadvantage obviously is you can only send binary data, so waveforms, stuff like that. And so those are the 3 and kind of the pros and cons of them.